For this problem, we're asked to factor, find all zeros, and then sketch a graph. So if we're going to factor this, we check how many terms there are, and then choose the method. So we have 4 terms, so we'll try grouping. If we group it, we get take an x squared out, and we get x plus 5. And then in the second 2 numbers, there is no GCF besides 1, and that's no good. Because notice that these 2 groups aren't the same, so factor by grouping in this case doesn't work, which is okay. It's not going to be as quick, but it's okay. If there is no factoring method, that's where we use our synthetic division to guess and check some zeros. And then once we've done that, that will naturally break it down into some factors. So the possible zeros, since the p's are plus or minus 1, plus or minus 3, and the q's are just 1, the possible zeros are 1 over 1 and 3 over 1. So there's only 4 possible rational roots that we have to guess and check. So I'm going to try 1 first. So 1 is going to give us, it looks like it's not going to work. We get 16. Now, I'm not going to throw this out and erase it and start over. This is actually good information. So recall that 1 is x and 16 is y. So 116 is a point on our graph. And we're going to keep that in the back of our mind because that could help us when we connect our dots. But we do know that 1 is not a 0 because it didn't give us 0 as an output. So we'll try negative 1. 1, negative 1, 4, negative 4, 3, negative 3. Hey, there we go. There's our happy 0. Okay, so what that means is negative 1 is one of our solutions. It also tells us that we have factored one step of this equation. So the factored form would be x plus 1, because if the 0 is negative 1, it comes from the factor x plus 1. And its cofactor is this 1x squared plus 4x plus 3. So that's how we use the synthetic division to factor, kind of guessing factors. Okay, well now that we have that, we can see if this quadratic factors, which it looks like it does. We're looking for 2 numbers that multiply to 3 that add to 4. So that's going to be a 3 and a 1, a positive 1 and a positive 3. All right, so that there would be the factored form of our equation. And then to graph it, let's figure out the rest of the zeros. This is going to give us x is negative 1. This is going to give us x is negative 3. So if we combine those with the current one, well, we had x equaled negative 1 once. Since we have another one, I'm going to put a little m2 to represent it had a multiplicity of 2. And then we had 1, negative 3. All right, so now we can plot what we know. We know negative 1. I'm going to put a little 2 by it to indicate that we had 2 of them. And we had negative 3. We also know that the y-intercept is at 0, 3. And we also know the point 116, which is way up here somewhere. That actually follows what we see here. If we have to go up through here, we're also going to go up through that point because there's no other x-intercepts that we're coming down through. Okay, so now we can connect our dots and then check our end behavior. So it looks like we're bouncing here at 2. So I'm going to come down, I'm going to bounce off of that, go up, and then down through negative 3. All right, so our end behavior is down over here, and then it ends up over here, which if we look at our leading coefficient, our leading term, that makes sense. This is a positive, it has a positive a value, so it's like a positively moving line because all odd degree functions move the same way. So it's going to have the shape like a line that's a positive slope, which is what ours does.